A spacecraft leaves Earth carrying the hopes of an entire scientific community. It doesn't head straight for its destination. Instead, it loops around the Sun 15 times. It swings past Earth once, Venus twice, and its actual target 3 times before it can even think about slowing down. The journey covers 7.9 billion kilometers and takes 6.5 years. All of that just to reach the closest planet to our Sun. Why would getting to Mercury be that hard? And what on earth or off it makes this tiny, scorched world worth such an extraordinary effort? Stick around, because the answers will change how you think about our entire solar system. If you've ever looked up at the night sky and felt that pull that need to understand what's really out there, then Celestial Secrets was made for you. Subscribe now, and join a community that never stops asking the right questions. Welcome back to Celestial Secrets, the channel dedicated to revealing what the universe is actually hiding. Today we are visiting a world that most people write off without a second thought. Not Pluto, drifting in distant darkness. Not Saturn, glittering with its famous rings. We are talking about Mercury, the planet so close to the Sun that it is practically hiding in the glare, and yet somehow, astonishingly, the least explored terrestrial planet in our entire solar system. Only 2 spacecraft have ever visited it. 2. Compare that to Jupiter, which sits nearly 8 times farther away from us and has been visited dozens of times. There is something deeply strange about that imbalance, and once you understand why, you will never look at Mercury the same way again. Let's start with what Mercury actually is, because it is almost certainly not what you picture. Most people imagine a featureless grey rock, baking silently beside the Sun. And while Mercury does superficially resemble our Moon, heavily cratered, ancient-looking, that comparison falls apart the moment you look at the numbers. Mercury is not primarily a rock. It is approximately 70% metal and only 30% silicate material. It is, by composition, more like a metallic cannonball than a stone. And because of that, it is extraordinarily dense, 5.427 grams per cubic centimeter, second only to Earth in the entire solar system. Here is what makes that remarkable: Mercury is tiny. It has been outgrown by 2 moons. Jupiter's Ganymede and Saturn's Titan are both physically larger. And yet both of those moons have a fraction of Mercury's mass. Scale Mercury up to the size of Earth, and its gravitational pull at the surface would be virtually identical to our own. That is the power of density. So what else is this dense little world hiding? Quite a lot, as it turns out, starting with its violent past. Look at Mercury's surface and you are staring at a geological crime scene, evidence of impacts, eruptions, and forces almost too large to comprehend. The most dramatic feature is the Caloris Basin, a crater 1,550 kilometers wide, formed by an impact of almost incomprehensible violence. The object that struck Mercury hit with enough force to trigger volcanic eruptions across the surface and send shockwaves reverberating through the entire planet. Those waves traveled all the way to the opposite side of Mercury, and when they arrived, they buckled and deformed the terrain into a haunting, jumbled landscape that scientists have simply called the weird terrain. It is exactly as strange as it sounds. And the temperature extremes on this scarred world? Brutal. On the side facing the Sun, temperatures climb past 400 degrees Celsius. On the dark side, they plunge to minus 173 degrees. That is a swing of nearly 600 degrees on the same planet. The reason is Mercury's near-total lack of atmosphere. There is nothing to trap heat, nothing to smooth out extremes. Just a wispy exosphere, a barely there shell of atoms constantly being ripped away by solar wind and constantly replaced. And yet, despite all of that hostility, water ice has been confirmed at Mercury's North Pole. Tucked inside craters that never see sunlight, frozen water has survived on one of the hottest surfaces in the solar system. Let that sink in. Now for the part that will genuinely make your head spin. Mercury completes one orbit around the Sun every 88 Earth days, a short year by any measure. But its rotation is so slow that it takes about 59 Earth days just to spin once on its axis. Because of a precise 3:2 resonance between its orbit and rotation, a single solar day on Mercury, from one sunrise to the next, lasts 2 complete Mercurian years. And it gets stranger. Mercury's orbit is the most eccentric of any planet. Its distance from the Sun swings between 46 million and 70 million kilometers. When it swings closest to the Sun, it accelerates dramatically. So dramatically, in fact, that for a brief window of about 4 days near its closest approach, Mercury's orbital speed actually overtakes its own rotation speed. The result? If you were standing on Mercury during this moment, you would watch the Sun rise in the east, then slow to a stop, then visibly drift backward, before eventually resuming its normal westward journey. The Sun moves backward in the Mercurian sky. Not as an optical illusion. Not metaphorically. Actually, physically, backward. This same quirk fooled astronomers for generations. Because Mercury was only in a good observational position every 116 days, and because it had rotated exactly twice in that period, early observers kept seeing the same face. They concluded Mercury was tidally locked to the Sun. It wasn't until radar astronomy in the 1960s that we discovered the truth. An entire planet, misunderstood for centuries, because of a cosmic coincidence. Here is the brutal irony of Mercury exploration: the closer a planet is to the Sun, the harder it is to reach. Not because of distance, but because of gravity. Any spacecraft heading toward Mercury falls into the Sun's immense gravitational well and accelerates. Slowing down enough to actually enter Mercury's orbit, rather than just fly past, requires burning an almost prohibitive amount of fuel. For 30 years after Mariner 10's flyby missions in 1974 and 1975, scientists could not find a solution that was physically and financially feasible. Mercury exploration was simply shelved. Then, in 1985, an orbital mechanics specialist named Chen-Wan quietly solved the problem, not with new technology, but with extraordinary mathematical ingenuity. She calculated a route that used the gravity of other planets as a natural braking system. Under her design, a spacecraft would orbit the Sun 15 times, using 1 Earth flyby, 2 Venus flybys, and 3 Mercury flybys to shed speed gradually, before finally slipping into Mercury's orbit on the 4th pass. The total journey, 7.9 billion kilometers. The total time, 6.5 years. NASA launched MESSENGER, the Mercury Surface, Space Environment, Geochemistry and Ranging Probe, in 2004. It was compact, just 1.8 meters long, but packed with instruments. It arrived at Mercury in March 2011 and spent for years in orbit, massively exceeding its planned 1-year mission. It was supposed to take 1,000 photographs. It took over 200,000, delivering a complete, high-resolution map of Mercury's entire surface for the first time in human history. On April 30, 2015, with its fuel exhausted, MESSENGER impacted Mercury's surface at over 14,000 kilometers per hour, ending a journey that had lasted over a decade and reshaped our understanding of the innermost world in our solar system. One woman's mathematical vision. one spacecraft, and an entirely new picture of a planet we thought we already knew. Mercury is proof that the most overlooked things are often the most extraordinary. A world hiding in the sun's glare, dense as iron, scarred by ancient violence, where time runs backward and ice survives beside scorching heat. We have barely scratched the surface. And the next mission, Colombo, is already on its way. If this episode made you see Mercury differently, imagine what the rest of the solar system has in store. Subscribe to Celestial Secrets, hit that notification bell, and never miss a discovery. The universe does not wait, and neither should you.